Hello, welcome to our work titled Improving Sound Event Detection with Auxiliary Foreground-Background Classification and Domain Adaptation. The task of sound event detection consists of identifying in a given audio recording the class of the active sounds as well as their onset and offset time. For the past years, the DCASE Challenge Task 4 has encouraged the development of this field by providing a baseline system to come up with methods to improve the detection of domestic sounds. Previous improvements proposed data augmentation schemes to improve generalization, the use of alternative time-frequency representations to log-MEL spectrograms, modifications to the backbone deep network architecture, and several post-processing techniques to refine detection scores. In this work, we propose two improvements to the detection of sound events in domestic environments. First, we propose to learn a foreground-background classifier jointly with a sound event classifier. Second, we propose a domain adaptation strategy based on optimal transport to reduce mismatch between synthetic and real soundscapes. In our first improvement, we propose to categorize domestic sounds according to their spectrotemporal characteristics. We regard rapidly varying sound classes such as dog, cat, speech, alarms, and dishes as foreground sounds, and slowly varying sound classes such as blender, vacuum cleaner, frying, running water, and electric shaver as background sounds. It is customary to train a sound event detection system with semi-supervised learning using a mean teacher model. We add to the model a foreground-background classifier that is trained jointly with a sound event classifier in a multitask fashion to improve generalization. We also explored the fusion of both classifiers into a detection branch to refine outputs. For our second improvement, we note that even though the semi-supervised learning paradigm to train sound event detection systems aims to learn invariant representations for synthetic and real data, there is still a mismatch that prevents generalization in real soundscapes. Our proposed strategy relies on optimal transport for its ability to find correspondences between samples by exploiting the geometry of the underlying space. We adopt the deep joint distribution optimal transport framework to correct the mismatch between synthetic and real data. The goal is to find the optimal transportation coupling between the empirical distributions of the feature embeddings and labels of synthetic and real data, enabling the alignment of the two distributions. The method consists of two steps to solve this optimization problem. In the first step, we compute the optimal coupling matrix gamma, fixing the parameters of the feature extractor and classifier. And in the second step, fixing the optimal coupling gamma, we update the parameters of the feature extractor and classifier. More specifically, for the task of sound event detection, after an initial pre-training stage, we sample active and inactive learned feature representations of synthetic and real soundscapes and construct an objective function to account for the mismatch between these empirical distributions. Following the previous adaptation procedure, we are able to reduce the mismatch between the distributions of active and inactive frames of synthetic and real soundscapes. We performed experiments on the domestic environment sound event detection dataset to test our proposed improvements to the sound event detection task. First, we showed that the foreground-background classifier improves generalization, increasing model performance from 8 to 10%. Second, the combination of a foreground-background classifier with a sound event detection branch leads to higher detection scores, outperforming the baseline by up to 11%. Third, our proposed domain adaptation strategy further reduces data mismatch between synthetic and real soundscapes by up to 13% in the validation set when combined with our first proposed improvement, and by up to 15% on the public evaluation set. Fourth, in general, HMM post-processing yields greater improvement over median filtering, but for the combined foreground-background and sound event classifiers, both post-processing schemes yield similar results, playing a similar role in the modeling of time-varying spectra of sound events. We also assessed the performance of model ensembling for the DCASE Challenge 2021, where our system showed competitive performances. In this work, we proposed two methods that enhance the detection of domestic sounds. We showed that learning a foreground-background classifier with a sound event classifier improves generalization of the latter, and that the fusion of both classifiers leads to refined outputs. We showed that our optimal transport-based adaptation strategy further reduces the mismatch between synthetic and real soundscapes. We also showed that the combination of the two proposed methods improves substantially the performance of the baseline system. Thank you very much for watching.